Okay, let's start the third lecture of the power electronics uh, for the G30 International Program in Nagoya University. And today, I will analyze the boost chopper. Boost chopper is later. Yesterday's lecture, in the yesterday's lecture, we have indicated complete boost chopper circuit. This one is a boost chopper. The main circuit is illustrated in the like this. This one is a power line, but to obtain the 48-volt constant, in case of the mild hybrid electric vehicle, we require the control circuit. We have indicated the drive circuit, and here we can require the control circuit for operating the boost chopper. But in today, I will focus to only the power circuit. Here is the power circuit. Okay. This analysis is very easy, so don't worry for analyzing. Okay. Because for very easy, this is we we can see that this IGBT, but this one is a famous switching device for the power electronics area, IGBTs. But this is we can look like only the switch. Ideal one for the analyze, we can see the switch. This switch is is very simple: on or off. So this circuit analysis is divided only the two analyses. One is the on, one is the off. So please write or illustrate the equivalent circuit in the turn on and turn off, and analyze the electric circuit. Okay, and this switch is only operate the turn on and turn off. So how about the voltage? Vs. And how about the current? IL. And first illustrate to the each parameter, IL and Vs. And this one's time. And the time is divided to the time on. Turn on term indicates the turn T on. Turn off term is the T off. And added time is the sampling one. And this one is a cycle to the like this. So turn on and turn off, turn on and turn off, on, off, cycling, on, off, on. In this timing, how about the IL and VS pre-indicate and more? And this one is the inputs 12 volt. This one is the output 48 volt.お腹すいた。なんでもない。in Japan, now it's around 9 p.m. But I cannot eat the supper, so I'm very hungry. So, okay. Input side. In case of the turn on, how about the current? Current flows through this one is turn on. This one is terminal, but where current is flows through like this, directly to go to the ground. Ground means here. So the upper positive side voltage, for the voltage, current flows through like this, group this one. So the equivalent circuit of in case of the turn on, the 12 volt inverter. In case of the ideal, the switch is we can look at only the wire. So this one is equivalent circuit. Very simple. And of course, the voltage is here. And of course, if you have the basic knowledge of the electric circuit, the current flow through here, and this, in case of this loop, the total voltage is the 0. So in this loop, this direction's voltage. So this one 12 volt indicate the V in, and this one is the V out. We will indicate the V in. This one is the V out. Total voltage is 0. So V in and equal V out. So total voltage is 0. Okay. Why occurred this voltage V out, this direction? That is the Faraday's law. Please check to your textbook for the Faraday's laws. And but for analyzing the electric circuit, please remember for example, this one. V R. How to analyze the electric circuit? First of all, please draw the current line. Draw the current. Current flows through all electric circuit is we must draw the current like a loop, okay? Plus battery plus side terminal to the minus side. Loop. This one is I. Okay. And second step. Indicate the voltage voltage line like this. Voltage arrow. Pay attention to this direction. Okay. Input voltage. Output, in case of the output voltage, this one is the current flows like this. But this component's name is the resistance. Resistance means the current flow through this direction. Resistance that opposite side. Okay, so that this one, VR. At V voltage arrow. Third step is obtain the equation. Equation means the equal. Equation have the equal. And this is a very important point. Current flow through the direction is here. The same side arrows, the same side directions, voltage is arranged to the equal side or left side. So this is this direction, current flow direction, the same one. So the arranged to the left side, and right side is the opposite side for the current flow through the direction. Current flow through the direction is in this case this direction, but voltage arrows line is the opposite side. This voltage is arranged to the right side. Very easy. We are in this component in this component we are very simple. Ri, Ohm's law. Very equation. Very simple and very easy circuit, but please check the 3-step. If you use this analyze, you can analyze the complicated and application side. As electric circuit, you can analyze that very easily. Okay, please remember this one. So how about in this case? This one is a very simple, but very important. How to analyze the electric circuit? Okay. Okay. Back to the analyze the boost chopper. In case current direction, first is a loop. You are in the loop. IL. This one is the IL. And we have already indicated each component's voltage. And finally, we will obtain the equation. The left side is VL, and the same direction is here. So the arrange to the left side. Right side is the opposite side direction for the current side. Current flows through like this, but this voltage for the inductors is opposite side, so the arrange to the right side. Right? Very simple. So from the Faraday's law, And this analyze if the start to the IL, IL, blue line. Start point, if you start point of IL, very simple one. And this current, in case of a turn on, this current value increased linearly. In ideal one, ideal discussion, these are linear. In the real world, this one indicates that the resistance, each passing of the devices, so that this one is not linear, upper side upper. But this one is ideal discussion, so the increase linearly. And we check that this difference is we delta I on, in case of turn on, this value is the difference. So we can indicate the TL, dt mean the T on, di mean the delta I off, delta I on. We can obtain this equation. How about the turn off? Where our load mean the outside. For example, the Toyota Prius have the, and the outside have the inverter. Of course, mild hybrid case, electric vehicle have the inverter and motor focus load, and the load, using the load, the each vehicle occurs the driving force. Okay, so outside we can look this output power, driving force mean the resistance はこうか。めっちゃ腹減った。And inside the V in air. Okay. First, current loop plus to minus. Okay. Second, this resistance and the V out. V out means this one. V out. Out power. V out. How was this inductor's voltage? Please consider how about the arrow's direction? This one side? What this one side? Answer is the direction is here. V air. Because input side for output side is the higher voltage because the boost chopper. Boost means the voltage boost one. Voltage boost. Okay, so the out voltage is higher than the input voltage. So to obtain the higher voltage, this regulation add this this voltage, we can obtain this one. So this direction, or that is one discussion. But the other discussion is the higher voltage. This current flows through like this, but this current direction is the target is the higher voltage point. So this current decreases. So this current will decrease linearly. Okay. So the current is decreased. So from the Faraday's law, current is this inductor want to current is keep the same this value. So the current flows through like this direction. They want to flow through like this current, the same value. So voltage across to this direction. That discussion is the Faraday's law. So equal, we will obtain the equation, the same direction, V in, V air, V out. Please, so V in, V in,この T オフですね。T オフ。じゃんじゃんじゃんに、2。You will define this value. This value will delta I off. And in the automotive application, we must keep this constant power. Of course, we must obtain the constant voltage, but uh, in the short time range, we must obtain the same power, the constant power. So for obtaining the constant power, this output voltage is constant. How to obtain the constant power? The in current power is indicated the voltage times current. So the voltage is the constant. So current average is the constant. This boost choppers in current must keep the constant average value. For obtain the constant average value, the delta I and delta I on equal delta I off. This one is an important condition to the voltage average is keep constant because the inductor on, off, on, off, on, off. the same. On off is almost the same. If the difference to the on off upper side or the on off lower side, this is not constant. So if we obtain the constant power, this condition is required. Okay, this equation is 3. Using the 1, 2, 3, this is each equation, we can obtain the, please calculate to the, V, please calculate V out equal V in. Please obtain this equation, okay? In the black box, white box, black box, using only the T on or T off, or please use this one, or this one, only, okay? Please calculate.今からやろうとしてもちょっとお腹 I'm very hungry, so the answer will indicate the next lecture. Okay? See you. 疲れました。